Okay, so our second lesson of unit number 1 is solving linear systems by graphing and its application. So basically we're going to do the exact same thing as what we did last class, but now we're going to look at it into the application form. We're going to start off with just translating a few phrases into the math language just to help ourselves understand some of the let statements and get ourselves more introduced to how to convert words to mathematical numbers. So the first one we have here is for more than a number. So we're going to have to introduce a number, and we're going to do that with the let statement. So we're going to say let x represent a number, and 4 more than a number would be just 4 plus x. Next one is 20 less than double a number. So again, we're going to say in this case, I'm going to say let n represent a number. You can make any letter represent a number. And it's 20 less than double the number. So we're going to double the number, and then we're going to do minus 20. A number decreased by 5 is 20. Is represents equal sign. So again here, a number, I'm going to say let p represent a number. So a number decreased by 5 is 20. So a number that is decreased by 5 is equal to 20. Sum of two numbers is 90. So in this case, I have two numbers that I need to introduce. So I need two letters. So my let statement should have two letters in them. So I'm going to say let x and y represent two numbers. Two numbers. So sum of two numbers is 90. Sum of two numbers is equal to 90. The next one is there are 60 more girls than boys at last. So here again we have two variables, which is the number of girls as well as the number of boys. So I'm going to say let G represent number of girls and let B represent number of boys. So there are 60 more girls. So the number of girls is equal to 60 plus whatever the number of boys there are at last. So girls is 60 more than the number of boys there are. Okay, moving on. So the calories in a piece of pie is 20 less than 3 times the calories in a scoop of ice cream. So here again we have two things that we're comparing. Piece of pie as well as scoop of ice cream. So I'm going to say let P represent the piece of pie, and let I represent scoop of ice cream. So the calories in a piece of pie is 20 less. So the calories in a piece of pie is equal sign, 20 less than 3 times the calories in a scoop of ice cream. So whatever 3 times the calories in a scoop of ice cream minus the 20 is basically how many calories there are in a piece of pie. Okay, and our last example here is the sum of two numbers is 4 less than twice the larger number. If the larger number is decreased by 3 times the smaller, the result is minus 20. So here again we're comparing two different types of numbers. So there's a larger number as well as a smaller number, so I need to make sure I make that distinction. Let L represent the larger number and let S represent the smaller number. So the sum of two numbers is 4 less than twice the larger number. So sum of both of the numbers is equal to 4 less than twice the larger number. So take the larger number, twice it, and minus 4. That's what's going to be equal to sum of the two numbers. So that's the first part of the equation. And there's a second part. It says if the larger number is decreased by 3 times the smaller, the result is minus 20. So the larger number is being decreased by the smaller number, so 3 times the smaller number. So I'm going to start off by 3 times the smaller number and decrease the larger number from it, my result is going to be minus 20. So in this case, there are two parts to that equation. There's the first part, which is basically just the first sentence, and the second sentence is represented by the second equation here. Okay, so hopefully that gets us introduced to being a little bit more comfortable with writing let statements as well as translating it into the math language. Okay, so let's go ahead and do an example. Okay, so I'll go ahead and read the example first and then I'll walk you through the solution. Okay, so here the question is, Ian owns a small airplane. He pays $50 an hour for flying time and $300 per month for hangar fees at a local airport. If Ian rented the same kind of plane at a local flying club, it will cost him $100 per hour. And again, there's no hangar fees here, so he doesn't need to store his airplane. And the question is, how many hours would Ian have to fly each month so that the cost of the airplane would be the same as renting each month? Okay, so we're going to start off with our let statements here. And in this case, we're comparing the cost as well as the time that we're actually flying the airplane. So our two variables are going to be, so two unknown things are the number of hours, the flying hours, as well as the total cost. And this we're talking about in a monthly sense. We're just talking about it in 1 month. Okay, so let's set up our let statement. So let C represent the total cost in dollars, and this is going to be monthly cost. And let D represents time in hours flown, and that's also going to be the time in a month. Okay? Alright, so for first part, this is when if Ian owns an airplane, he has to pay $50 an hour for flying time, as well as $300 a month just for hangar fees at the local airport, just where he can actually park his airplane. So there's a $300 charge, that's a flat fee, and then there's a $50 per hour charge for his flying time. So my total cost is going to be 50T, because that's the number of hours that I'm going to be flying. That's every hour is basically $50, and then the $300 just to store the airplane. Whereas in the second part, if Ian is just renting his airplane, there is no hangar fees, but there is an hourly fee. It's $100. So in this case, it's going to be C equals to 100T. So whatever the amount of hours that he's flying his airplane, he has to pay $100. Once we got our equations figured out, we're going to go ahead and graph both of the equations and be able to figure out how many hours would Ian have to fly each month so that the cost of the airplane would be the same as renting. Okay, so when we're graphing this, again, we have to make sure that we're going to be looking at our y-intercept along with our slope. So for the first equation, my y-intercept is 300. So I'm going to start off my axis where I have on my x-axis time, and the y-axis is the cost. And the cost is going up by $100, so it's 100, 200, 300, all the way up to 600. And time is basically in hours, so I'm going to start off with 1, 2, 3, 4, and onwards. To graph the first one, my intercept is 300, so it's a $300 charge. Regardless of if I'm flying the airplane or not, I have to pay $300 just to store the airplane. And it's $50 for every hour. So this is, each box here is 50, so I'm going to go up 1 and then 1 across, because that 1 across is basically 1 hour. So 1 up, 1 across, 1 up, 1 across, and you're going to keep doing that until you have yourself a set of points where you're going to join them with a straight line. And that is basically for the first one. This is if Ian owns the airplane. So I'm just going to write down owns. And the second part, I don't have a y-intercept here, so it's going to start off with 0. And it's $100 for every hour. So I go up to 100, and that's for every 1 hour. So go up to 1 across, up to 1 across, up to 1 across. And you're going to keep doing that until you try to get yourself to a point where they're going to intersect, and then you're going to join that line, and this is if Ian rented. Okay, so if you notice, the point of intersection is 6 and 600, so what that means is if Ian was to fly his airplane for 6 hours, the cost would be $600 for both renting as well as owning the airplane. So for how many hours would Ian have to fly? Ian would have to fly for 6 hours, so that the cost of the airplane would be the same as renting the airplane for a month. Okay. Alright, so this is just an example of an application type of question that you can see. Now in this case, if you notice that the equations were provided to you and then the graph was also provided, so we just basically walk through the solution. So let's go ahead and look at another example in similar context. Alright, so I'm going to read the question and I'll walk you through the solution again. Okay, so Brian and Catherine wanted to get internet access for their home. There are two companies in the area, IT Plus, that's the first one. It charges a flat rate of $25 a month for unlimited use. So no matter how many minutes or how many hours you're going to use the internet, you just have to pay $25 every month. Whereas Techies Inc. charges $10 a month plus $1 for every hour for use. So if Brian and Catherine expect to use the internet for approximately 18 hours a month, which one is a better option for them? There's two ways of doing this question, and since we're looking at graphing our lines, we're going to go ahead and actually introduce and write down what our lines are and graph them, but you can actually go ahead and plug 18 into each one of the equations to figure out which one would charge more. But in this case, I am looking for you guys to be able to graph these two equations. So in order for us to graph, we're going to have to come up with our let statements first to introduce our variables. So in this case, we're looking at the cost as well as the time in hours. So we have two variables, C and T. So let C represent the total cost in a month. So again, we're looking at monthly cost. And let T represent the time in hours. And then again in a month. Okay, so let's set up our two equations. The first one, which is the IT plus, there is only a flat rate charge. There's not an hourly charge. So my C is going to equal 25 only. So no matter how many hours I use this, I just have to pay $25 and that's it. And my second equation, it's $10 per month plus $1 for every hour that I use the internet. So Techies Inc. is going to be 1T, so T represents the number of hours, plus 10, and 10 is my fixed cost. So once I got my two equations set up, I'm going to go ahead and I'm going to graph these. So for the first one, C equals 25. There's no slope here, it's just a y-intercept, and that y-intercept is basically continuing. So in this case, you're basically just going to go ahead and draw a horizontal line of 25 across, and that is going to be IT plus. And my second equation, there is a y-intercept of 10. So I'm going to start off with 10, and I have a slope of 1. So it's $1 for every hour. So in this going up by 5s, so each box is 5, and same thing here. So that means if it's $1 for every hour, it's going to be $5 for every 5 hours. Another $5 for every 5 hours. So you're going to continue that until you're going to go an intersection or just to extend your line. So we're going to line, that is going to be Techies Inc. Alright, so if you look at the point of intersection, that is 15 and 25. So that's for 15 hours, both companies, IT Plus as well as Techies Inc., will charge the same amount, which would be $25. The question here is, Brian and Catherine expect to use the internet for approximately 18 hours a month. So which plan is a better option for them? So 18 hours is approximately right there. So if I draw myself a vertical line, just see, I'm going to move this a little bit. If I draw myself a vertical line at 18, approximately here, You notice that IT Plus would charge $25 regardless of how long you're using the internet for, but Texas Inc. is going to charge a little bit more. So in this case, IT Plus would be cheaper. So which plan is a better option for them? IT Plus would be a better option because it's cheaper. Okay, great. So now we're going to look at an example where we're not going to be given the equation or the graph, but we have to walk ourselves through all that. Okay, so here's an example. It says Arlene is looking into cell phone plans. Cell Plus, first type plan, gives unlimited minutes for $50 a month. Elsa offers $40 monthly fee, 5 cents per minute, for any time over 300 minutes per month. There's a little condition here, so when we're setting up our equation, we have to be really sure with how we're going to be incorporating 300 minutes per month. So let's get started. This is my second cell phone plan. So let's get started. The first question is write a linear equation to represent the charges for each company. To write equations, we need to introduce our let statements. So in this case, we're looking at the cost as well as the time in minutes. And again, we're comparing this in a monthly charge. So let C represent the total cost. I'm going to say total monthly cost. And let T represent the time in minutes in a month. Okay, so our first equation, which is our cell plus, is going to be C equal to, there is only a fixed cost here and there's no cost in terms of the number of minutes of usage for the cell phone. So in this case, it's just going to be C equals to 50, no matter how many, for how long you're actually going to be using your cell phone. The second one is LCell. In this case, there's a fixed cost, which is $40 a month, plus 5 cents per minute for any time over 300 minutes per month. So if we're under 300 minutes, that means we only pay $40. But if we go over 300 minutes, we then have to pay an extra charge of 5 cents for every minute that we go over 300. Okay, so let's see how this is going to play. So in this case, my cost is going to be $40 only if time happens to be less than 300 minutes. But if time happens to be greater than 300 minutes, my equation is going to change slightly. It's going to be 40 plus the 5 cents per minute. And 5 cents is 0.05 of a dollar. So it's 0.05 T. And this is only when T is greater or equal to 300 minutes. So basically what this means is if I use my phone less than 300 minutes, I only pay $40. But if I use my phone for more than 300 minutes, not only do I pay the $40, but I also have an additional charge of 5 cents for every minute of usage. Okay, hopefully that makes sense. If not, I will clarify that in class as well. Alright, so now that we got our two equations, in this case it's partially three equations because the second one has two different parts. So we got the two equations to find the point of intersection. So when we're graphing equations, we always need to set up our axes first. In this case, we're dealing with time as well as the cost. So I'm going to put time in my x-axis. And again, the time is going to be in minutes. And C is going to be the cost. And that's going to be in dollar amount. For time, since I'm dealing with 300 here, so it just makes sense for me to go with an increment of 100. So I'm going to start off with 0 here. So I'm going to do increment of 100, 200, 300, 400, 500, 600, and 700. I think I'll stop right there. And I'll continue if I need to. And the cost here is increments of 10. So it's, I see a 40 and a 50, so I'm going to go up by 10s. So that's 10, 20, 30, 40, 50, 60, and 70. And I'll stop at 80. So when I'm graphing my first equation, cell plus, that's equals to 50. So that's just going to be a horizontal line where there's a y-intercept of 50 and there's no slope at all. So I'm just going to draw myself a horizontal line. Be sure to use a ruler. I'm going to draw myself arrow because that will continue, and that is representing cell plus. Alright, now to graph my second equation, it says C is 40 only when it's less than 300. So if I'm using less than 300 minutes, that's the cost is going to be just 40 until right there. So I'm going to draw myself a horizontal line right there. So I only paid $40. Sorry, Charlene only pays $40 if she's using her cell phone less than 300 minutes. But if she goes over 300 minutes, there's an extra charge of 5 cents per minute. So after that, I'm going to have actually a slope, which is 5 cents per minute. 5 cents per minute is technically looking at $5 for every 100 minutes. So I'm just going to write that down here. So if it's 5 cents for 1 minute, if I look at if I'm using my phone for 100 minutes, because if I notice that my x-axis is in the increment of 100, so for 100 minutes, so this is 5 cents, it's going to be basically $5 for every 100 minutes, because this is 0.05, and I'm just going to multiply that by 100 to get the $5, okay? So it's $5 for every 100 minutes, so every box here is representing $5, so I go up 1, and I go across here, because every box here is represented by every box is represented by 50, so 2 boxes is representing 100. So I go up 1, 2 across, up 1, 2 across, up 1, 2 across, and I'm just going to extend that line. And this is going to be L cell. Okay. So my point of intersection here, if you notice, is 550. So the question here is, what does point of intersection represent? It represents the fact that at 500 minutes, both cell phone plans would charge $50. So at 500 minutes, both phone plans would charge $50. Okay, and our last question here is, which plan does Charlene choose if she estimates that she will use her phone 10 hours per month or 6 hours per month? So there's 2 parts to the question. So for the first part, if she uses her phone for 10 hours, and I'm just going to convert that to minutes because my time in my graph is in minutes. So 1 hour, there are 60 minutes. So in 10 hours, there's going to be 600 minutes. So I'm going to go to my graph and see at 600 minutes, which phone company is going to be cheaper. So I'm just going to extend that line. If you notice, Cell Plus would be cheaper because it would only be charging $50, whereas L Cell would be $55. So in this case, Charlene should choose L Cell. So sorry, Cell Plus. Cell Plus would be cheaper here. And for the second part, if Charlene is using her phone for 6 hours, and then again in minutes, that is 360. So again, going to my chart here, 350 is right there, 360 is just a little bit above 350. And you're going to extend your line. Here, L Cell would be cheaper because it'll be less than $50, whereas Cell Plus would be $50 regardless of the amount of phone usage you use. So in this case, L Cell would be a better option. Okay. I will again go through this question in class, making sure everyone understands this. Please bring your questions to class, and we will work on this homework as well. If you want to get a head start, please do so. Alright, thank you.